So we are on worksheet 18, maybe, or is it 19? 18, right? 18 AB and 19, and I don't think we're going to need to flip back and forth too much. That little bit right there is old news from last year. It says you need a Trig reference sheet. I'm not real sure why, but we'll figure that out as we go. And I hope you were been thinking about how you did or didn't prepare for that quiz and what you need to come in and retake. All right, on the top of worksheet 18, it says you can use the same techniques you learned for graphing sine and cosine to graph the tangent and the reciprocal functions. The general form of tangent is here. All right, you will not have a phase shift on the quiz. You could have A, B, or D changed. A is a vertical compression or stretch. B changes the period, and D is a vertical change, shifting the graph up or down. As for what the tangent actually looks like, that's not a very good unit circle when it's an oval, Hofbauer. All right, tangent is actually slope. Do you remember that? Okay, so what is the slope of, if we start rotating at 0 right here, what is the slope right there? Do you remember slope of a horizontal line? 0. So therefore, the tangent starts right here. Now, as I, hang on as I rotate around, is the slope getting steeper or less steep? It's getting more and more steep. Does anybody know what the slope would be at pi over 4 or a 45 degree? How much over and up do you go? Yeah, they would be equal. So the slope is going up until it hits 1 at pi over 4. All right, then the slope continues to increase, and it can get really steep, right? Really, really, really steep. So what happens is this is increasing dramatically until what happens right here? Yes, this is no slope or undefined slope, right? So when we get to pi over 2, there is no slope and there's an asymptote on the graph. Now, as we move into the next quadrant, what happens to the slope of that line? It is negative, but very negative, right? It's going down very quickly. It's actually down here somewhere. Then as you get over here to 3 pi over 4, what happens? That has a slope of, anybody know that one? You'd go over and up the same amount, so this would be a slope of -1. Everybody okay? Making sense out of that? So at 3 pi over 4, the slope is at -1. And then when we keep getting less and less slope until it gets back to what at pi? 0. So the slope is decreasing until it gets to 0. Now, that's one period right there. Because anything down in this quadrant is the same slope as what we already saw over in the first quadrant, right? They're all just extending those lines. So that's one period. Now, we don't think of it as one period because, oh yeah, let me try that again. It's not really what it looks like. Okay, anyway, we normally look at it as going from like negative pi over 2 to positive pi over 2, and there's an undefined place here, and there's an undefined place over here at 3 pi over 2. So if you start at 0, my graphs are really bad, it should be doing like this, okay? If you started talking about it at 0, the up branch, the asymptote, and the down branch here would go from 0 to pi. So the period is pi, not 2 pi. And that means when we have a b value, the new period will be pi over b for this function, not 2 pi over b. Now, is this an even or odd function? Where's the symmetry at? Origin symmetry, so it's odd. You are not going to have to label a lot of ordered pairs on this. What you would need to know was that it goes through 0, 0, and that it has asymptotes at pi over 2, negative pi over 2, 3 pi over 2, and at pi 0, it's back. You're not going to have to label points in between. Does that make sense? Just the intersections and the asymptotes, okay? So here it shows again the asymptotes, the domain, it's actually undefined at every pi over 2 and then pi later. So all the multiples of pi over 2, all the odd multiples of pi over 2. And it has y-intercepts at the even multiples, so 0, pi, 1, pi, 2, pi. Yep, that's good enough. What about amplitude? The definition of amplitude is max minus min divided by 2. Does this have a maximum or a minimum? No. Okay, so the period is pi. The new period will be pi over b, but the term amplitude does not apply to a tangent graph because it has no maximum or minimum. All right. So at the top of 18b, what would the new period be if I were to graph this? This is review. Sine 3t, what would the period be? Period would be what? Sine graph would be 2 pi over 3, right? If it was a cosine graph with b of 5, maybe I need to separate that because there was some confusion on the quiz. The b is the number in the equation, but the period is the normal period divided by that. So if this is a cosine, it's 2 pi over 5. But when it's a tangent with a b of 3, what's the new period? It's just pi over 3, okay? Tangent is an odd function. So here, tangent with a period of pi, but when b is 4, the new period would be pi over 4, okay? So what really happens, let me just reiterate this one more time. If this was the graph that I had to do, this pi over 3, it means it does this branch and this branch and finishes here at pi over 3. So the asymptote would be halfway there at pi over 6, which means there would be the negative 1 at negative pi over 6. And then this is 1 pi over 6, 2 pi over 6, 3 pi over, oh my gosh, 3 pi over 6, so there'd be an undefined place at pi over 2 again. That was a horrible picture. Do you want me to try to do this one, pi over 4? If I were graphing tangent for x, the period would be pi over 4, so it would do this and this by pi over 4. So where would the undefined place be, guys? What's half of a pi over 4? Pi over 8. And that means on this side, there's also an undefined place at negative pi over 8. So every pi over 8, something is happening. So we have 1 pi over 8, 2 pi over 8, So the next undefined place here would be 3 pi over 8. Everybody okay? All right, that was worth taking our time to do. This one, this is a vertical stretch. It's not the amplitude. It just means it goes up 3 times faster. Does that really going to make a big difference? No. Okay. The period, if B is 4 pi, the period would be the normal period of pi divided by 4 pi, which would make it what? 1/4 is the new period. 1/4 means it's finishing a whole cycle here by whoops, that's not going to have an asymptote there, by 1/4. So 1/8 is, and then the down branch would be between 1/8 and 1/4. And on this side, we'd have negative 1/8. Those are where the asymptotes are. So where would this next asymptote be? Negative 3/8 or positive 3/8, yep. Okay, it should have a, what?
Wait, why is it? Oh, no.
Because that's what we were counting by.
I thought you were saying.
If I were to graph this on the calculator, somebody remind me, what did it say?
3 tan 4 pi x.
Okay, I'm in radians. The window was like, what, negative 1/2 to 1/2 across? Up and down?
Like 4.
So negative 4 to 4 that I have here will work? Maybe I didn't change this to 1/2? How's that? Does that look more like what we were kind of doing? If we traced to pi over 4, oh, it was 1/4, thank you. Trace to 0.25, thank you for fixing me. At 1/4, is that what we had at 1/4? Okay. All right, I'm going to put that on here. Moving on. What's going to happen here? The negative tangent shape would just mean it reflects, so it's going this way. Does that seem okay with everybody? Okay. That's the negative tangent shape. And what is this 1/2 going to do? If B is 1/2, the new period is pi divided by 1/2, which would be 2 pi. So now it does this and this by 2 pi. Just kidding. Thank you. It does this and that, right? Because isn't this a distance of 2 pi from here to here? Okay. So it would do this again.
Is that shifted at all, or is that how it looks like?
No, it's not shifted, it's just stretched and okay, somebody tell me what this one said. Negative tan of
1/2 x.
0.5, I'll put x. And the window was like negative 3 pi to 3 pi?
Yeah.
I'm gonna leave mine 4 just because I'm too lazy to fix it. Is that what we got? Or would have? Okay. So the asymptotes were at x equals negative pi. This one is at x equals pi. And then the zeros would be at negative 2 pi 0, 0, 0, to pi 0. You will have to label 2 asymptotes and 2 zeros on the quiz. Questions? All right. The next one we're going to talk about is cotangent. Cotangent is the reciprocal of all these values. I'm going to go kind of quick here, but what is the reciprocal of 0? This dotted line is tangent, okay? No, the reciprocal of 0 is not 0. Undefined, right? Because 1 over 0 would be undefined. You good? Where the other one was undefined, anybody know?
It was undefined at
Tangent was undefined at
its first.
pi over 2, but what is that going to do when we have reciprocal? How did we get undefined? Because the slope was,
Zero.
so instead of doing
It would.
okay, let me try again.
It would.
It was horizontal here, the line on the slope of 0 was a horizontal line, so the slope was undefined, or the slope was 0, so we had undefined. When we got to pi over 2, we had a vertical line, so the tangent slope was undefined, but the cotangent would be 0. Okay, same here, where this was 0, it will now be undefined. Now, where this was really tiny, like 0.1, what is the reciprocal of 0.1? 1/10, what's the reciprocal? 10, so it's very high, okay? This was up at, say, 1, it's still at 1 at pi over 4. Reciprocal of 1 is 1. But if you had like a value of 10, as it approached pi over 2, the reciprocal of that would be 1/10, so it gets very small. Did that help anyone understand why this happens?
So it's just the negative.
But shifted. Yes. I did that wrong. That's not an asymptote. Where there was an asymptote, it will have a 0. Where there was a 0, it will now have an asymptote. Okay, so there's cotangent. So the period is still what? Is pi still. If we do one here, can you tell even or odd? It doesn't go through the origin, but if we rotated that 180, I think it would still look the same, right? So it is still odd. It says here, it is an odd function, okay? Any questions about that? So it says number 3, we should do this. Cotangent of 2x, what is that 2 going to change? The period. Now, cotangent, did it go through 0, 0 when it was a cotangent graph? No. There was an asymptote here, and then it went over here, and then there's another asymptote, okay? But we're going to do the period has changed. B is 2, so the period is now pi over 2. So this would be pi over 2, where the next asymptote is. So where would it cross at? Pi over 4. And tangent is this way, so cotangent is this way. Now you could do one go on this way. It's probably what I would have done. Negative pi over 2. Oh, you could have done another one going that way. Question? So what do you have to remember? On the quiz, for tangent and cotangent, it's most likely the only thing we would change would be the period, okay? So you got to memorize the shape. All right. Cosecant, this is a sine graph on here. Does everybody see that? The cosecant, every place that the sine graph had a 0, what's going to happen when you do the reciprocal of 0? It's going to be undefined, yes? The reciprocal of 0, 1 over 0 is undefined. Everybody with me? Okay, so that means it's going to have an asymptote at all these places that the sine graph hit 0. Okay. Yeah. Oh dear, moving the wrong thing. Let's try this. I wanted to scoot you over. There you go. Okay. Right here, this was 2 pi, right? So this would be pi. Everybody okay for the sine graph? So here at pi over 2, what did the sine graph hit? 1. What is the reciprocal of 1? 1. So this cosecant graph still hits that point, pi over 2, 1. But where these tiny little values were getting less than 1, like 1/2, what's the reciprocal of 1/2, guys? 2. 1/10? 10. This gets infinitely large. And the same thing going this way. Over here at 3 pi over 2, it was -1, so it stays -1. The reciprocal of -1 is -1. But the values as it got closer to 0 would get infinitely large on both sides. So if you had to graph this, you would tell me where these asymptotes were. They are at x equals 0, x equals negative pi, x equals pi, x equals 2 pi, x equals 3 pi. That's those. And the zeros in between, this one would be at negative pi over 2, -1. I'm sorry, it's not a 0. It's actually what? To this little branch, it's a, anybody know what that point would be called right there? A maximum? Does that make sense? This one would be a minimum at pi over 2, 1. Then there'd be a maximum at 3 pi over 2, -1. And this would be a minimum at, what would the next one be? 5 pi over 2, 1. Okay. Sine and cosine are just shifts of each other, yes? So therefore, secant and cosecant are also just shifts of each other. Guys, the deal is you would graph the cosine graph first, and then everywhere that it hit 0, what are you going to do? You're going to put an asymptote. This is too small. I don't like this graph. Okay. Anytime you're asked to graph a secant graph, you would first graph the cosine, then you would figure out where all the asymptotes are, You would figure out the amplitude of that cosine graph, and then you would take each of those little maxes and min pieces and do what to them? Flip them, yes. So, by the way, the asymptote is not officially part of the graph. So this is what the secant graph looks like. Can you give me 3 ordered pairs quick? This would be 0, 1. Now be careful. The asymptotes were, where's 2 pi on this graph? Because there's cosine. This is 2 pi, right?
Yes, that bottom is.
This is 2 pi 0. This bottom guy would be at pi -1. By the way, this was 1, not 0, my bad. So where are the asymptotes at? X equals pi over 2, 3 pi over 2, 5 pi over 2, or negative pi over 2. Everybody okay? Now, in the blue, did I do 1 period? I did a period and a half, right? So, all right, here's what they look like. I don't even have them memorized. I always just graph a sine or cosine and then put in the asymptotes and flip the pieces over. Does that make sense? All right, real quick. Cosecant right here, even or odd? Secant? Right, because we can fold it here. Okay. All right, so the quiz will say graph 2 periods, label the asymptotes and any maximum or minimum pairs for this kind of a graph, okay? So number 4, what am I going to graph first? Y equals, what's the reciprocal of cosecant? Please. We're going to graph 2. What's the reciprocal function for secant?
Oh,
So this is what we're going to graph. Okay? Period, or the amplitude will be 2, so the maxes and mins are going to occur at 2 and -2. Everybody good so far? Cosine starts at the max. I'm going to dot mine. And finishes at the max 2 pi later, right? But what is this going to do to it? 2 pi over 3. So this is going to be 2 pi over 3. And I'm going to do one in the negative direction as well, because I'm supposed to graph 2 periods. So we'll decide how much of that we need eventually. So this will be -2 pi over 3. Have I lost anybody so far? Because we just took secant out and put in cosine. The amplitude is 2. A cosine graph starts at the max, finishes 2 pi over b or 2 pi over 3 later. Okay, we need to put some more ordered pairs in before we try to figure this all out, I think. What would halfway to 2 pi, what are the quarter points? I need to call them quarter points because you did not do well on the quiz with this. If the period is 2 pi over 3, you divide that by 4 to get the quarter points. 2 pi over 3 times 1/4 would be 2 pi over 12, which is pi over 6. This is a pi over 6. 2 of those would be 2 pi over 6 or pi over 3. 3 pi over 6 would be, okay, so this was pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Those are the quarter points. And going this way, same thing. Okay, now we're finally, I think, ready to graph the actual function we came here to graph. Where do I put the asymptotes? Wherever there was zeros. So that will be an asymptote at x equals -pi over 6 over here at x equals pi over 6, at x equals pi over 2, x equals negative pi over 2. Okay, then what do? I flip them all, so this little U shape here goes this way instead. And it has a minimum at 0, 2. This one here goes this way, and it has a maximum at pi over 3, negative 2. This one here, I can draw the whole thing if I want, but at 2 pi over 3, it is back up at 2. There's one over here. That has a minimum at negative pi over 3, negative 2. There, I drew 2 periods, didn't I? 2 complete cycles. So we're good? So what's the most important thing to remember about that? Completely draw the reciprocal function, right? But just make it dotted. Anywhere that there was an asymptote, or that there was a 0, you make an asymptote. Anywhere there was a local max or min, it's still a max or min, right? But you're going to flip it over. What was a max will become a min, etc. All right, so real quick, tell me how to do this one. Okay, what can you tell me about the sine graph that I'm going to draw?
It's going to be,
The amplitude is 3 and negative 3.
it's going to be 1 pi period.
Okay, 2 pi over 2 makes the period pi, which means the quarter points are every what? 1/4 of a pi. So there's a pi over 4, 2 pi over 4, which would be a pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 halves, 7 pi over 4, 8 pi over 4 would be 2 pi. If you just want to go positive on this one, you can. Where do I put the asymptotes? X equals 0 is an asymptote. Where's the next one? X equals pi over 2. X equals pi. 3 pi over 2 and 2 pi, right? Which you can't tell on mine. That's 2 pi. All right, and then what do? I flip all these little u's, so there is, instead of a maximum, local maximum here, there's a minimum at pi over 4. Remember, it was up at 3. And at 3 pi over 4, oh my goodness, that was horrible. It's down at negative 3, and so on. Is that good enough, guys? You get the idea? Quarter points are hugely important. Did you guys have a graph for that one? That you had to try to match? Okay. I hate when they give me a graph. It's a struggle for me.
On the next one.
We have a graph on the next one. Hopefully I do too. Everybody okay? All right, what are we supposed to do to this guy? What's the plus 3 doing? Moving it up 3. So we are going to graph sine x plus 3. So the midline is going to be up here at 3. And it's going to go, the maximums are going to be at what?
2,
The maxes and mins are going to be at 2 and 4, right? Sine graph starts at the midline. It has no period change, so it should finish at 2 pi, which is here, by the way. This would be 1 pi, half a pi, oh, I was supposed to dot that. Three pi over 2 would be up at 4. Negative pi. Okay. So that's enough for me to draw the asymptotes in. Somebody give me the equations of the asymptotes. Yep. X equals negative pi. X equals pi. That's not negative pi half power. That one's 2 pi. Oh my goodness. Oh, mine are just so scribbly. Okay, and then what? All these little things flip over. Can anybody give me the minimum point right there? Negative 3 pi over 2, comma 4, right? And this one down here would be at, by the way, there's also an asymptote at x equals 0. So this one, anybody? Negative pi over 2, comma 2. The next one would be at, anybody got that one? Pi over 2, comma 4. And finally, one more over here at 3 pi over 2, comma 2. Is that 2 periods worth? Yes? All right. Ugh, there's another one? Oh, this is the last one. All right. What do you know about this one? We're going to graph cosine. Y equals, can I write it as cosine of 1/3 x? And then shifted down 1. So the midline is down at negative 1. It's a regular cosine. So it starts at the max, which is actually 0, right? Because it only goes up and down 1. So it would look like this. And it would go down as far as negative 2. All right. What is the period? 2 pi divided by 1/3 would be 6 pi, right? And so the quarter points would be 6 pi over 4, or every 3/2. So this is 3 pi over 2. Another 3 pi over 2 would be 6 pi over 2, which would be 3 pi. The next one would be 9 pi over 2. And then 6 pi is where it finished here. Go in the other direction. We have the same numbers, but negative. I'm not going to put them all in. Everywhere it crossed that midline is where there's an asymptote. And then we would take all those and flip them around. And just make sure we did 2 complete periods. Everybody okay if I stop there? Because I want to talk 1 second. The very last question on the homework is a graphing question like this. 2 secant x equals 5 secant x, and you're just supposed to answer as decimals. How do you put secant in your calculator? It's 1 over cosine. So 2 secant, you would type 2 divided by cosine, or 2 times 1 over cosine. And then it said, where is it equal to 5 sine x? That one you don't need a reciprocal. And then you would look at the graph and you would find the intersection points and how often they are repeating. Or I think the question in the book says all you have to do is between like negative 2 pi and 2 pi. So if you set your window there from negative 2 pi to 2 pi, then you find all the intersection points, but all you want is the x value. So you're the decimals of the intersection points, only the x value. Okay, number 37 in the book, you're going to want to do on the calculator. The book work is found, can somebody tell me? What worksheet is this on? 277, but it's on worksheet 17B, which was actually part of the last homework check. So if you turned your homework check in, you need to yank back out worksheet 17B, okay?
What does it mean in radians?
Make sure your calculator's in radian mode.
Oh, okay.
Other questions?